Thanks. Welcome to this presentation. I'm Fabio. This is my third, I think, presentation at PyCon. I was here also last year talking about something with Python, but related to cars and simulation of cars in urban systems. This year, I tried to find something new. But first of all, just a few questions about myself. I am a civil freelance engineering. I'm working on transportation networks in general, but usually as a consultant for companies or public administrations. As an engineer, working actually giving answers to problems related to traffic and transportation planning in general. So I think today the first thing to do is to decode the title. Because I imagine that if you are not familiar with these topics, it might be a little bit complicated. But still, the first part of the presentation is going to develop some and answer some questions about the title. So first thing, map. So today we are not going about talking about maps in that way, but we are talking about how to map flows. So flows in the sense of information, if you want, but in the transportation point of view, you can think of flows in terms of traffic or passengers, trains, buses, etc. Okay, so more of this later, but we are talking in this kind of mapping today. Second thing, this is the simple one, transportation networks and transit systems. So we are mapping transit systems, so railways, buses, trams, underground systems, and so on transportation networks. Also, this is easier. I think you are familiar with this type of visualization. This is the railway network in the UK. So this is this was the simple thing, and now we are going into maybe the new thing. So first thing is how to work with the GTFS data in Python. So this is a common format for transit feeds. It was developed by Google. We have two kinds of information. You have static data, the one we are talking about today, or also live, so they live updated and in real-time information. Essentially, they are a simple zip file with some text files inside the folder. And to understand in a better way what we're talking about, this is a simple call of a trip from my hometown, as also my address, to here, so Grande Hotel Mediterraneo in Firenze. And you see that we have, or better, Google Transit split the trip in different parts. So basically from Treviso to Venice and from Venice to Firenze. We have here in these parts, Google reads the GTFS data coming from the national radio provider, for instance. And for the other parts, we have the urban bus path here. So here is reading data from the municipality, or better, I don't know, I don't know, remember the name of the company here in Firenze, but from the urban system data. And then at the end, it's just basically connect the closer stop from the final location to a walking path. Okay, so basically when you call this kind of research, Google is reading the GTFS data that companies are giving to it in order to get all the information about trips. What about the structure? So focus only on the green tables because they are the required files for the whole package. Basically, we have in the middle the trip, and this connected with the routes. We have lateral things like the agency, so basically the name of the company which provide the data. And also all the information about the stops and stop time. So basically a timetable of information of your service. So how about working with this kind of data with Python? We have, if you're looking for packages, we have plenty of things. I tried the first one, the GTFS kit. It's nice because it has also a native support for Shapely, because we can have, I forgot to tell that here, we have also information about the shape of the path. It's not required, but we can have. So with the first package, you can also, it's nice for visualize data, since we can handle also coordinates and so on. Also another package with nice tools for mapping information. But still, sometimes when we are working with this kind of data, we are not sure that they are well validated. So the first thing, and maybe is the easiest thing to do, is to use pure Python to read the files. Basically, just open the folder and read table by table or file by file, basically text file, with all the things that we are interested in. Just a few things to take a look. The first one is that the GTFS data go beyond the midnight, if you want. So sometimes you can find this kind of time format, and it's a bit scary, but it's just because try to keep for a service that starts, I mean, in the middle of the day and ends the service at the day after. So in this kind of way, you can have the full trace of the service without basically having some issues with recognizing the single service. So keep mind of this thing. And the other thing is, since the data are coming from different data providers, we can have also some issues about the types. For instance, now we are talking about two data sets. In one case, the service ID is an integer. In the other case, is a string. So you know that with this kind of things, when you should try to map or search look for the same service in different tables. If you have the different type, it's a mess. So just be aware of these kind of things. How about the availability? Usually companies have to publish free this kind of data, but it's not, sometimes it fails in this kind of sense. But there are some things we can explore. So in this presentation, well, actually I use this kind of, the link. This portal, they offer free, sometimes free part of GTFS data for railways in Germany. But if you go to the cost, you see that we have, yes, a free part of data, which is basically static data with no particular updates. And then when you pay more money, you can have more specifications, or basically not free data, because you can go also into live feeds and so on. So, but basically for our needs, the basic stuff is okay. So we can just download the package you need. We have a long distance rail, local transit for the whole country. And the second package I use is coming from Italy. It's coming from Venice. Sorry, it's a bit, but still we have the free data, open data from the municipality of Venice, of Venezia, and divided into the car services, so buses and trams, and also this is nice because Venice is a particular way of moving for people, of transit system, about the navigation, so boats, actually boat services in the city. So last thing to decode the title is Infomap. This is one of the, in my opinion, one of the best and more interesting clustering, network clustering algorithms developed so far. You can find the references here from the Martin Rosvall and Bergstrom. The idea, it's a bit complicated in a mathematical point of view, but the idea is to try to find communities here, not only based on the structure of the network, but on the flows. So you can imagine a random walker working on the network in a random way. And the more the walker goes into some particular structure, the more that structure should be clustered. So this is the main idea, to find information, and it's useful when you're talking about flows in networks. And you see that there is some basic examples of what Infomap can do, just to find connections between or among different topics of science, psychology, psychiatry, economics, and so on, and giving the idea of how much, in this case, how much citations are going from one node to another. And it's fine because now we are going to do a risky live demo, and it's running also on the web with a very, very nice interface. So this is the full title, and I hope that it's more clear now. And the workflow for this project is so basically coming from the transit data through GTFS. We are using NetworkX, so a simple package to work with network to get information from the timetable to a waiting network, and export some basic text files into Infomap to get some results about information about clustering. So the first step is reading GTFS data, but we saw that it's easy, and then putting the information into a graph with NetworkX. We use the multi-day graph, and we get some information about stop times, and getting some weights into the network with basically travel time or the number of trips from one node to another. And basically from getting incremental information, we are getting this big graph for the services we want to model. And the second thing is to model a type of network for our needs. The first one is the so-called directed service network, DSN. So in this case, we have the weight as the number of services from one station to another. But it's nice also to explore some information about the travel time in the second network, where we have the same topology associated with the mean travel time between two nodes. So basically extracting then the output format for Infomap, it's straightforward, because Infomap can read basically source, target, and weight column-based file. But I think that it's better to go into the demo now. Oops. Okay, so this is Infomap online. Yes. Infomap, of course, well, is a package written in C, but is very easy to work with Python. Just from the installation thing, is supporting only Python 3. And here we have all the things about this is a bit scary formula, but actually, as I said before, the mathematical context is not so easy, but it's useful to get a look. But it's not so difficult at the end. And then you have also all the information for the installation and so on. And about the input formats, it's nice to have a look at here, the project format, which is basically a list of nodes with their names, and the list of edges, in case you can also add a third column with the weight. So basically how it works. We can load a network. Here we have, for example, let's go with this is the Intercity Express from the GTFS from Germany. So you can load, you see that it's nice because we can have the name of the station, so it's better recognizable. Here we can choose the parameters, also from this nice tool. So the tree, because it's nice, is useful for and required for the visualization here in the web page. This is for the network visualization, and also we have to get the directed network, because in the transportation things we have to take consideration of the direction of the services. So let's see, it should run here, okay. You can, this is pretty new, show network. You can here get, we have no information about the location here, just the structure. We don't have coordinates of the nodes, but still you can have information and visualization of the network. But the nice thing here is that you can run actually the Infomap algorithm on the network. This is the service for Germany. You see that you have different levels of clustering. This is the big Berlin node. If we can go within the node, you can see that we have the inner structure of the services from different stations of Berlin or just the surrounding. Or even we can go here to Frankfurt. You see the Frankfurt Airport Station, Frankfurt Main Station. So you can explore different levels of clustering in terms of visualization. If we run the things about Venice, let's do with the all both services from Venice with the same options. Okay, this is nice because we have a big structure. So basically, they are the main services on the main island, and then we have small isolated nodes with small services that are completely disconnected from the full network of Venice. And oops, but regarding the main structure, you can see here that we have Troncheto, so it's basically the railway station, Rialto, so the main touristic places. So you can explore visually here, or when working directly with Python, here you can also get all this information about levels and flows as a text file and explore in a better way. So let's have a look just a few things about the travel time networks to check the differences. So we have the same network of Venice, but in the terms of travel time, you see that we have a different structure. Here we have two big clusters from Punta Sabbioni, which is a location a little bit disconnected from the main island of Venice, but still they have full services that can connect this kind of locations to the main town of Venice, if you want. And here in this, oops, and in this big node, you have the inner Venice services. Remember that we are talking about travel times, so this kind of clustering is based since we have more or less comparable travel times in this node that different from the other ones since we are completely, well, far apart. I think should be on time, okay, more or less, okay, fine, perfect. So I'm going to just a bit little and brief conclusions. So in this kind of talk, we had just an overview of GTFS file and how to work with and read them with Python, and how to use the data to build networks and get information about transit data. And also how to recognize as Infomap as one of the best, I think, clustering algorithm in town so far. And since we have also this kind of big, very nice interface, web interface, it's nice to get some information just to explore data and then going then deep into information with pure Python or get other stuff. Okay, thank you for your attention.
extra time for questions because there's still like, almost like 6-7 minutes.
Okay.
I have one question to start a Q&A, and reminder for everyone, there's Slido, so if you want to ask questions, you can go to the schedule and ask the question. You showed us a lot of data about Germany and some data about Venice. How do you get that data? What about data from other cities? What about other places? How available is that data?
Yes, from I think it was a list of potential other data providers here. Real-time data. Well, you have to look for, yes, you see that here you have agencies. They are only from Germany, I think, but that should provide the GTFS data. In Italy, apart from Venice, actually, I don't remember any other agencies that they are providing so for free the data and just to download the zip files and do what you want. But still, sometimes, as I said before, companies should release this kind of data to Google, of course, but also to the public, since they are public data. Just basically, this is another representation of the timetable that you can find on their website and so on. So it's not easy. So you have to go into the deep web and trying to find data. Yeah.
Okay. So speaking of those timetables, we have one question from the audience. How do you write programs with robustness to handle temporary service changes?
I don't understand, sorry, the question.
As far as I understand the question, and maybe if somebody else the question is in the audience here to clarify, but I think it means that if you have like the timetable and that timetable had like a change for a month
okay,
or
yes,
something.
yes, sorry, yes. We use in this case only static data. Yes, it's a good question. In theory, you can use the real-time GTFS data, but they are not so popular, so it's difficult to find the static data, so it's more difficult to find also live data. And also live data is a delicate topic since usually companies are not releasing live data from their services since someone can analyze the data and say, okay, oh, you are going very slow in this kind of, of road, or oh, your service is worse than ever, and so on. So it's a little bit delicate, yes.
Okay. So there's a follow-up question. Are GTFS data good proxies for mobility of people?
Well, no, because it is only the offer, so it's only the timetable. We don't have information about how many passengers are traveling from one node to another. So no, it's just the offer. So it's a first step, but then we have to put above the data other information about the demand. Yes.
Could you maybe infer some of that data based on the density of connections? Like if there's connection from one place to another every 5 minutes, then it's probably
you can find you can find information about maybe for from the frequency. You can get information about how popular is that path, but nothing about the amount of passengers, for instance. Yes.
Yep. So we have a different question. How would you use this type of analysis in consultancy? What is the business case behind using that data?
Well, in this case, sometimes agencies can or want to find the inner and hidden results from the data. I think that working with the Infomap or getting different information, for instance, like travel times or different structures of the timetable, sometimes they are interested in knowing something more from their data, because sometimes we just release the data just to get the information about traveling, but sometimes they are very precious just to discover maybe some hidden patterns that they don't want to, don't know that they have in their company, in their agency.
Okay. We still have a few minutes left. Do you have any questions here in the room that somebody wants to ask? I don't see any questions, so I think that's it.
Thanks
Thank you,
much.
Fabio.